Jupiter may be the first planet humanity can never truly survive near. From Earth, it looks calm. Bright bands, a steady glow in the night sky. But the closer spacecraft moved toward Jupiter, the more unsettling the reality became. Radiation strong enough to damage electronics from millions of kilometers away. Storms larger than planets. An atmosphere with no surface to stand on. Then NASA sent Juno into orbit around Jupiter in 2016. And what it found forced scientists to rethink not just Jupiter itself, but the limits of human exploration. By the end of this video, you will understand why Jupiter may represent one of the hardest environments humanity has ever attempted to explore. For decades, Jupiter was treated as the gateway to the outer solar system. It is the largest planet orbiting the Sun. You could fit more than 1,000 Earths inside it. Its magnetosphere stretches millions of kilometers into space. Its moons contain hidden oceans, active volcanoes, and some of the strangest environments anywhere in the solar system. In science fiction, Jupiter often felt inevitable, another frontier waiting for human engineering to catch up. That assumption made sense. Human history is full of places once considered unreachable. Antarctica, the deep ocean, orbit itself. Each time, technology narrowed the gap. And from Earth, Jupiter still looks deceptively familiar. Bright, silent, almost peaceful. But scale changes everything. The closer spacecraft moved toward Jupiter, the more one fact became impossible to ignore. This is not simply a larger Earth. It is a world built on completely different rules. The first warning sign was radiation. When NASA designed the Juno spacecraft, engineers already knew Jupiter's environment was dangerous. Earlier missions had detected enormous radiation belts surrounding the planet. But the actual conditions turned out to be worse, far worse. Jupiter traps charged particles inside its magnetic field and accelerates them to extreme speeds. The result is a radiation environment powerful enough to gradually damage spacecraft electronics, corrupt instruments, and threaten missions over time. Juno needed a titanium radiation vault weighing nearly 200 kilograms simply to protect its onboard computers. Even then, mission planners carefully designed its orbit to minimize exposure whenever possible. Scott Bolton, Juno's principal investigator at the Southwest Research Institute, later said the mission revealed Jupiter to be far more complex than expected. Not because one measurement was wrong, because entire models of how the planet worked had to be reconsidered. And radiation was only the beginning. Jupiter's magnetosphere is the largest planetary magnetosphere in the solar system. Its magnetic moment is roughly 20,000 times Earth's, creating a magnetic environment unlike anything surrounding the other planets. Earth's magnetic field protects life. Jupiter's traps radiation. It captures charged particles and hurls them through surrounding space at enormous energies. In parts of the inner Jovian system, unprotected human exposure to radiation could become lethal on timescales ranging from hours to far less, depending on location and shielding. That alone changes everything about exploration. With current technology, ordinary spacewalks near Jupiter's inner system are unrealistic. Permanently crewed stations in close orbit would face extraordinary radiation challenges. Every spacecraft entering the system must survive invisible particle bombardment strong enough to slowly degrade electronics over time. And then there is the planet itself. Jupiter has no known solid surface, no oceans to splash into, no mountains beneath the clouds, no ground waiting below. The deeper you descend, the denser the atmosphere becomes, hydrogen compressing into exotic fluid states under pressures and temperatures unlike anything found on Earth. Deeper still, scientists believe hydrogen transitions into electrically conducting metallic hydrogen. A spacecraft falling into Jupiter would not land. It would sink, crushed by pressure, heated beyond survival, swallowed by an atmosphere thousands of kilometers deep. And the violence does not stop there. The Great Red Spot is not a normal storm. Juno data revealed that it reaches hundreds of kilometers downward into the planet. The storm has been observed for at least nearly 2 centuries, and possibly longer if earlier observations describe the same system. That means humanity has existed through generations of a storm that never fully stopped. Jupiter's gravity reshapes its moons as well. Io, the closest large moon, is stretched and compressed so intensely that its surface erupts constantly. Massive volcanic plumes blast material hundreds of kilometers into space. Europa likely contains a global ocean beneath its ice shell, one of the strongest candidates for extraterrestrial habitability in the solar system. But reaching that ocean means surviving Jupiter first. Even robotic probes face enormous engineering challenges operating there long term. Not everyone agrees that Jupiter is uniquely unconquerable. Future shielding technologies could improve. Autonomous systems may eventually tolerate conditions humans cannot. But the scale matters. Every environment humanity has mastered still obeyed limits our technology could eventually adapt to. Jupiter may test those limits in entirely new ways. It feels less like a destination and more like a boundary. On July 4, 2016, the Juno spacecraft approached Jupiter after a journey lasting nearly 5 years. At Mission Control, Scott Bolton and his team waited through 35 minutes of orbital insertion with no real-time communication possible between Earth and the spacecraft. If something failed, there would be no way to intervene. Juno would simply disappear. The spacecraft had to perform its engine burn alone while descending toward one of the harshest planetary environments NASA had ever attempted to orbit. Then the signal returned. Juno survived. That moment mattered because the mission was never just about Jupiter itself. It was about discovering whether human engineering could continue pushing deeper into environments once considered unreachable. Juno delivered extraordinary science, but it also revealed something humbling. The spacecraft survives Jupiter only by carefully managing radiation exposure, adjusting orbital paths, and accepting gradual damage to instruments and electronics over time. Every close pass carries consequences. Even our best machines cannot operate there indefinitely without damage. That realization changes the emotional meaning of exploration. In modern space culture, exploration is often imagined as the first step toward eventual settlement. Jupiter suggests a different possibility, that some places in the universe may always remain hostile to permanent human presence. NASA's Europa Clipper mission is now traveling toward Jupiter's system and is expected to arrive in 2030. Its goal is not to land on Jupiter, but to study Europa's hidden ocean and determine whether conditions for life may exist beneath the ice. But major questions remain unresolved. How long can spacecraft reliably survive inside Jupiter's radiation environment? What exactly exists inside Jupiter's diffuse interior? And if Jupiter represents an engineering limit for current technology, where are the limits beyond it? Science has encountered moments like this before. In the early 20th century, many experts doubted practical spaceflight, even as rocket pioneers argued it was possible. Later, some scientists dismissed the idea of landing humans on the moon. History teaches caution against declaring limits too early. But Jupiter may force us to ask a harder question. What if some limits are real? Jupiter is not simply a large planet. It is a world so extreme that humanity may never fully exist within it in the way we imagine inhabiting other worlds. No solid surface, no forgiving close orbit, no environment that easily tolerates mistakes. And yet it continues pulling us closer. Because Jupiter represents something larger than danger. It represents the edge of what human civilization can currently reach. For centuries, exploration carried the assumption that every frontier would eventually yield to persistence and technology. Jupiter quietly challenges that belief. It reminds us that the universe is not scaled for human survival. Some worlds can be visited, some can be studied, and some may only ever be observed from a distance. Jupiter has existed for about 4.6 billion years, not as a future home, but as a reminder that the cosmos does not need to be habitable for us to be drawn toward it.